a presentation on comets. I give it a title. It's called Curious News About Comets. And the first slide here shows you a comet crossing the sky. And believe it or not, this is taken from a book, an old book, where this was an actual scene that people saw in the sky. An amazing thing. Now, you should know that in the past, comets were actually kind of ominous. People considered them to be kind of scary and really, you know, didn't really didn't like them. They usually were ominous portent. You know, they kind of said something bad was going to happen. So this is from the Book of Miracles, 1550. And yeah, that would have been an amazing thing to see. Nobody alive today has seen something like that. But this should happen from time to time. So you never know. This may happen in the next few years and we'll get an amazing sight. So comets are kind of fun. Let's talk about what a comet is. A comet is a small icy solar system body. The nickname is a dirty snowball. And when it passes close to the sun, it heats up and begins to outgas. Okay, and we learned this word, hopefully you learned this word, it's called sublimation. When the solid material, the solid icy material in the comet is hit by the heat of the sun and the energy of the sun, it turns straight into a gas it's this process called sublimation. Okay, so it can have an atmosphere around it temporarily in this time. It's called a coma, and also possibly a tail. The closer it gets to the sun, the more likely it's going to have a tail. And these phenomena are due to the effects of the solar radiation and the solar wind. Okay, comet nuclei range from a few hundred meters to tens of kilometers across. This is from Wikipedia. They are a loose collection of ice, dust, and small rocky particles. Okay, so one of the primary separators is that we have some comets that are called short period comets. They come from the Kuiper Belt, and they have periods that are less than 200 years. On the other hand, there are some comets that take a lot longer to do their orbit, and some of them will take from several thousand years or even millions of years. And these come from a place, a theoretical place called the Oort cloud. So I'm going to show you a little picture here. So take a look at the top right here. Pluto, as you remember, goes into the Kuiper Belt. It's a Kuiper Belt object now. And so we have this belt that goes around the solar system outside the orbit of Neptune called the Kuiper Belt. And then if you go very, very far out, this is a theoretical place. It's spherical in shape, and it's called the Oort cloud. And it could have billions of comets, right? Billions of them. So these are the essence of the comet, right? So the nucleus of the comet is the hard part, and the coma is the gases around it. So do comets always have comas? And the answer is no, they do not. When they're far from the sun, when they're near aphelion, or not even aphelion, it doesn't even have to be that far, when they're not at perihelion, when they're not closest to the sun or closer to the sun, then they don't have a coma. Okay, so it's a temporary thing. Now, if you could look inside, you might see something like this. This is actually an animation based on a mission called Giotto that flew up to see Halley's Comet. And this is supposed to be like a rendering of what Halley's Comet looks like. Okay, there's Halley's Comet. So the cool thing is that the comet has a tail as well. And so the comet tail, number one, you'll notice always goes away from the sun. But one part of the tail is called the ion tail. Don't call it gas tail. I wish I would update this graphic, but it's ion tail. And then the other one is called the dust tail. So ions are charged atoms. And it turns out that the solar wind is made of charged particles. So they interact very strongly, and it's really straight. It always goes directly away from the sun in the direction of the solar wind. But the dust tail can remember a little bit where the comet was. So it doesn't go behind the comet the way that it came from. It's really blowing in the solar wind. Okay. Here is Comet Hale-Bopp, and just as a quick question, right here, this is the Andromeda Galaxy. Which one's closer, the comet or the galaxy? If you were not in an astronomy class, I would actually probably get a 50-50 response, right? But because you're in the astronomy class, you probably know that a galaxy is very, very far away. We're talking millions of light years away. And the comet is really close, within a few AUs, if we have a pretty picture like this. So you can see the very straight ion tail, and it's kind of blue in color here, and then a curved dust tail. Okay, so this is made of ionic particles. This is made of larger dust particles. Actually, kind of an interesting story. Hale-Bopp there was a group that thought it was the end of the world, and they actually all committed suicide, right? It was not the end of the world. Don't do that. Okay, here's Halley's Comet. Again, Halley's Comet, the Giotto mission flew up to get a close look. The first time that we'd flown close to a comet. That was in 1986, the last time Halley's Comet flew past. Most of you were probably not alive, but you will be the next time it comes around. We're going to talk about Halley's Comet. Halley's Comet is one of the few that is actually named for someone. And the reason why is really kind of cool. Edmund Halley saw the comet and managed to figure out what its orbital parameters were and predicted that it would come back in 1758. Now, unfortunately, he died in 1742. He never got to see it come back, but his prediction was noticed. People took notice and they realized that he was correct. And they were so impressed that, that the comet was named for him. So the thing about Halley's Comet, it's kind of interesting. It doesn't come by very often. And in fact, most humans will never be able to see it more than, maybe twice, right? Twice is pretty much the best you're going to do. If you were a young person the first time you saw it, then you could see it as an older person. But the next time it comes around, you're probably not going to be here. Human lives are too short. So how long is Halley's Comet? Halley's Comet has an orbital period of about 75 years. I thought it was closer to the 76, but anyways, 75 years. And the next time it's going to reach aphelion, which is furthest from the sun, is December 9th, 2023. We know this very precisely. And the next time it hits perihelion, which is what you want to see, is 2061. Put that on your calendars, right? 2061. Halley's Comet's going to go flying across the sky. Finally, you get to see it, Halley's Comet. Now, you'll notice from this picture, it is not in the ecliptic plane, right? It's orbiting up it comes from below the ecliptic plane and then up, goes around the sun and then back down below the ecliptic plane, okay? And this is kind of typical. You'll also notice that the orbit is not circular. It's highly eccentric, right? That word eccentricity is very elliptical. Okay. So one of the cool things we mentioned, right, is that when the Earth flies through the debris left behind by a comet, we get a meteor shower. These are predictable. And I actually have a link here. You can click on the link and you can actually get the meteor shower. Let's just do it. Why not? Let's just do it. So if I do that, then actually I'm going to go ahead and go to the link for you. Here it is, the American Meteor Society, the Meteor Calendar for 2021. What's coming up next? Here we go. From July 12th to August 23rd, with a peak July 28th, is going to be called the Southern Delta Aquarids, right, in the constellation of Aquarius. Okay, and then after that, oh wait, the Alpha Capricornids. Whoa, coming up. The peak is almost the same time. Unfortunately, the moon is very bright, so I'm not sure if that's going to be very good. And the Perseids, very famous, right? The Perseids will peak on August 11th, 12th. Anyways, these are things that you can look up. Meteor showers are very predictable. And the reason is because the Earth is passing through the same part of its orbit every year, right? At that same time. Now, these are particularly good when the comet has just gone by, right? The sooner, the less time has passed, the more intense the meteor showers will be. So that's why some years are better than others. Okay, I want to tell you a little bit about how we've learned about comets. Here's a mission called Starcatcher. And the mission went to go get a sample from a comet called Wild 2. And actually, it was pretty amazing story. So the mission was flawless. It flew right into the tail of the comet and then caught comet dust in this very specially designed mitt, if you will, like a catcher's mitt for catching a baseball, but it's a specially designed material. And then it flew back to Earth. Everything was flawless. And then it landed. It was on its way to land, and the parachute failed, and it crashed in the desert. And everyone was devastated because this was an amazing mission. Everything had been flawless except for the very last stage. It crashed in the desert. They went to the desert. They collected this this apparatus, right, brought it back to the lab, and they found that the catching material was sealed and intact. And they took it back to the clean room, and they found inside little tiny pieces of comet dust. So again, just to make it more fun, I want to share with you something interesting. The material that they used was very, very special, and it's called aerogel. So here is a chunk of aerogel. Just a little side fact, I made this stuff as part of my dissertation, and it's pretty difficult to make. If you're interested, come to my office hours and ask me questions, and I'll share that with you. I do actually have some little chunks of it. I don't have big chunks like this. I used to have a pretty big chunk, but unfortunately, a student didn't hear my instructions not to press it very hard, and it got broken. But I can show you my my chunk of aerogel. Let me show you my chunk of aerogel that I have. Okay, so I've got another camera. Oops, sideways. Here, let's go. Okay, so I've got a little tiny box here. And when I look inside the box, there are my chunks of aerogel. Okay, so they're not quite as big as the pieces that you saw with the guy, but they are awesome, and they're translucent. Yeah, I don't know if you can see. You can see through them, and this is a hydrophobic, which means that it repels water, silicate aerogel. The ones that I made with my dissertation were called titanium dioxide aerogels. You don't need to know that. That's gratuitous information. Okay, back to our slideshow. So again, it's a little gratuitous, but you know what? It's kind of more fun for me to tell you a little story. One of the things to understand is how do you catch these little particles of comet dust, right? I mean, it should be easy, right? Well, unfortunately, it's not easy. And I want you to understand why it's so difficult. These particles are moving thousands of miles an hour. And so they have a lot of kinetic energy, right? So in fact, if you just stop them suddenly, what happens? They destroy themselves with all that energy. They just burn up, right? They're just gone. I want you to imagine you're trying to catch a little tiny piece of comet dust from its tail, and you don't want to destroy it. How do you do that? Okay, so this is totally gratuitous, but it's another story that I want to share with you. How do you, as a human being, jump out of a plane without a parachute and survive? Okay? And so I'm going to go ahead and tell you a little story. You don't need to know this at all, but it's just kind of amazing. If you want to fact check me, that'd be cool, because I have two stories. Number one is World War I. There's an American bomber pilot, and he is flying over Dresden, Germany, and he's going to bomb a munitions factory, a place where they build bombs, right? So he's flying over, getting close to the city, and the Germans saw him coming, right? They actually saw the plane, and the anti-aircraft guns fired up, and they hit him, right? And the plane wings, the plane was on fire, actually, and the pilot couldn't get to the rest of his people. They jumped, right? But the pilot had to eject out of the front of the plane, okay? But as he jumped out, his parachute caught on the fuselage and actually got caught on fire and burned up, and he had no parachute. So he is at 20,000 feet above the ground, and he's falling without a parachute. Can you imagine what that must have felt like? So just by luck, because that's all it could be, is just luck, he happens to land exactly on the factory that he was supposed to bomb. So good thing he didn't bomb it. So he lands on this factory, and he didn't land anywhere on the roof of the factory. He landed right on a skylight, you know, a big window in the roof of the factory. And what happens when his body hit it? Shattered it, and immediately, you know, shattered it. But listen, it slowed him down a little bit. And right underneath the skylight was a catwalk, a little passageway from one side of the factory to the other. In fact, there were a whole bunch of those, and he hit each one and broke it each time. 6, 7, 8 of them. I don't know how many there were, but he broke each one, and every time it slowed him down a little bit. And then he finally landed on a wooden crate and crushed it, right? So he lands on the factory floor on a wooden crate, and the workers look at him like, where'd you come from? He had broken nearly every bone in his body, but he survived, right? So that's kind of amazing. And what's the secret, right? What's the secret? You want to think about that. How do you take something moving really fast and stop it, right? You don't stop it all at once because that will destroy it. Same thing with a human, okay? The second story is even better, okay? Second story, a Swiss airline is flying over the Alps, and actually somebody planted a bomb. Okay, that's not a nice part of the story, but the bomb went off and a hole blew open in the fuselage of the plane. Nobody died, by the way. Actually, this is crazy, nobody died. But the hole blew open and the stewardess was sucked out the opening, just minding her own business, right? Everybody else was strapped in, but she was, doing something, walking around the cabin. She got sucked out and plummeting down 20,000 feet above the ground. And in her memoir, she wrote, she survives, right? I'm telling you. She wrote, she thought to herself, at least I'm going to die in my most beloved Swiss Alps, right? So they're flying over the Alps. And she must have been steering or something, James Bond kind of thing. She must have directed herself a little bit. If you've ever gone skydiving, you can do that. But anyways, she landed right on the top of a mountain, okay? So she didn't fall quite as far as she could have, right? Except that the mountain was completely covered with trees, these tall pine trees. And can you imagine what would happen if a human landed on top of a pine tree? Yes, shish kebab, right? That wouldn't be good. But it turns out she didn't land on the tree at all. She landed just between the trees, and she broke every single branch on both sides, right? There were trees all around. She broke all the branches as she went down and then landed in a 15-foot embankment of snow. And she got up and walked to the nearest village and told them, I just fell out of the plane. Anyways, that is for me an amazing example of something I never thought would happen, but in fact shows us the secret, right? When you want to slow something down, you don't slow it down all at once, it's just a little bit at a time. And these aerogels have that capability. They are 99+% air, right? They're almost entirely air. And so when the particles fly in, they don't hit a solid thing, they hit something that just slows them down a little bit at a time and then finally stops them. Okay, so let's take a look at the actual particles, right? So if you look right here, you can see, oh, this is just some cool things. Aerogels are so great at insulating because air is an insulator that you can put things like this. Kind of amazing. And here, yeah, it's got some strength, but not that strong. Please don't crush my aerogels if you ever get a chance to hold them. Here is an actual picture, right? So you can see that the particles penetrated, and at the end of every little bubble is a single particle. And they were able to take those out and analyze them and find out what comets are made of, right? So this is pretty amazing. So what did they find? They found that this is made from things that came from the young solar system, and it has a very interesting mixture of low and high temperature components. Some of the dust that's in there is called calcium aluminum inclusions, which can only form at high temperature. So this thing that we know is a ball of ice actually has some other interesting little pieces in it. Must have formed earlier, maybe in collisions or other events, okay? So they're a big mix, but they are, in essence, a time capsule from the early solar system, and that's why we're so interested. All right, so here's another story, and this is going to be a quick one. It's called Deep Impact, and this was a very interesting study where they dropped a vehicle from the mothership, and it's supposed to land and smashing into the ground create a crater. Okay, so deep impact. Make a crater, and then by measuring the material that flies off of the crater and measuring the size of the crater, you can determine something about the comet. So in fact, this is the video showing you the impact. Okay, I'm getting tired. And it ends right there. This is the flash of light that was at the moment of impact, came out of the comet when the impactor hit. And what they did is analyzed the light and basically used spectroscopy, which is the idea that each chemical compound has its own specific colors of light that are associated with it. And from that, and so here's the impact, right? So before and after, there's a little tiny crater. I know it's blurry, not sure what I can tell you. I can't see it very well, but they claim that this is a new crater that wasn't there before. Okay, sure, why not? Okay, so what did they find? It had much more dust than expected and less ice than expected. And the dust was very fine, like talcum powder. So if you've used baby powder at some point or you've touched it, you know how fine that powder is. But some of the material were clays and carbonates, which form with water, right? So carbonates have carbon in them, sodium, carbon dioxide, right? Sodium and crystalline silicates. Okay, so that's kind of cool. But here's a big one. Write this down. Comet was mostly empty space. It's more like a snowbank than a solid chunk of ice. Comets are incredibly porous, right? So they have lots of empty space. And this is a really interesting thing for you to know. Okay, I'm going to tell you more about this later. Okay, so here is the light signature, right? They looked for water, they found water. They looked for carbon dioxide, they found carbon dioxide. They looked for dust, they found dust. Okay, and so again, this just shows you some of what you can do, right? This is spectroscopy, where you're looking at specific kinds of molecules in this way. Okay, and now I've saved the best for last. This is the most amazing mission. This is a testament to humanity. This is from the ESA. You're supposed to know that's the European Space Agency or Space Administration. Oops, what is it? ESA, European Space Administration. Okay, that's probably what it is. ESA, and it's called the Rosetta mission. Please write that down, the Rosetta mission with the Philae lander. Oh my gosh, what a wonderful mission. And where did they go? They went to Comet 67P, also known as Churyumov-Gerasimenko. And it's just an amazing mission. It's super, super cool. In fact, I could teach a whole course on this one mission, and I'm just going to give you 15 minutes right here. Just a 15-minute quick story about it. But it was really, truly revolutionary. This mission went to fly to a comet that was coming in towards the sun, and then accompanied the comet as it went around the sun and watched what happened as it heated up. And it's pretty cool, amazing. Okay, so here's the timeline. You don't need to know any of this, but the mission arrived at the comet in 2014. It mapped, it did all kinds of research, and then the end of the mission was September 2016. So for 2 years, basically, this mission was studying the comet. And what did we learn? Well, pretty much everything we know about comets is from this mission. Not everything, but this is single-handedly one of the most important bits of information about comets that you're going to find out about. Okay, so here it is. This is here it is right here. It's about 4 kilometers by 4 or 5 kilometers, 3, 2, something like that. It's a few kilometers wide. It has 2 lobes, right? So this is it turns out to be a pretty common thing. We didn't know that at first, but we are now discovering that these 2 lobes probably smash together at low velocity and then join together. There's a neck joining them together. Some people call it the little rubber ducky, right? I don't know if you can kind of see it, a little rubber ducky. But anyways, there it is. The pictures that you're going to see are the most detailed pictures of the comet that have ever been taken. Remember, it started flying next to the comet before it had gotten close to the sun. So before it had a coma, and then watched the coma develop, and then once the coma had faded away, it finished its mission. Okay, so way too much information, just wanted to show it to you. But here we go. This is one of the first images, a close-up picture of Churyumov-Gerasimenko. And I look at this picture, and I mean, just the beauty of it. This is a picture of a comet, right? But the cool thing is, if I look at this and I imagine that I don't tell you that it's a comet, could you imagine this as a location on Earth? And I mean, I'm sure some of you are thinking, I've been to a place like that. I've seen something like that. And there's no clues, right? Except when you see it, it's very barren. So maybe some of you would say like a desert. And if you go to a desert, you might see a scene just like this. So there's something familiar about it, even though, you know, it's incredibly different, right? It's not like Earth, right? It doesn't have a regular atmosphere like Earth. It doesn't have weather. But here we go. It has like mountains, and it has, you know, this rubble, and it has sandy, but it's not sand, right? It can't be sand. It's going to be little grains of ice. And then I want to share, oh, okay, so not yet, sorry. So there's a lot of study here. This is so many PhDs, you know, it's not even funny, but they chose to name each section of the comet with an Egyptian god. And so that's kind of the theme here. Way too much information. I just want you to be aware that this has been done. If you were interested, you could go look it up, but you won't need to know a lot of information. And then this is, you know, some of the quick things that they were found. There was dust covered, pitted and brittle, large scale depression, smooth, rock-like, right? There were all these different areas that they found. Here's a really interesting picture. This on the left, we have a picture before the sun hits. And I don't know if you can notice, but it's very dark, right? Comets are covered with a fine layer of carbon and other carbon-containing compounds, organic compounds. They have a very low albedo, right? And then here the sunlight hits it, and you can see there's like a ghosty image here. Well, that is a jet of material coming out of the interior of the comet, right? When you heat it, some of the solid material turns to gas and it starts jetting out. And it doesn't just jet out gas, it takes pieces of the comet with it, right? And that's why there's a trail of debris behind the comet. Okay, that's pretty cool. This was so fun when this picture was published. The experts were just hanging, their mouths were open, and they had no idea what was going on. Can you imagine sand dunes on a comet, right? And nobody expected that. I think that's my favorite part of this. No, I didn't, you know, I'm not an expert at this. I'm just watching and fascinated. But I love the experts saying, we have no idea how this happened. What is this? So if I ask you the question, how do sand dunes form on Earth? I'll wait a second for you to think about that. And the answer is wind, right? Wind blows, and little by little, the dunes form, right? So is there wind on a comet? Well, there shouldn't be, because there's no real atmosphere. But people came up with some ideas, and maybe it's a jet, a horizontal jet across the surface. Anyway, they did come up with some explanations, and they made simulations that could do this as well. But just fascinating, right? Things that we had never seen, didn't predict. Okay, way too much information. Just to be aware, the sunlight coming in when it hits the coma, which contains, all of the gases that came out of the comet, chemistry happens, right? So what happens is that the light of the sun can make molecules join together until you get chains of molecules sometimes. So when I talk about the organic compounds, some of them are pretty complex. And the way that they would form is from the energy from the sun. Okay, so that's a key idea right there. Another interesting thing, this is just too much stuff here. Don't worry about it. But there's a magnetic field around the comet. Yeah, you don't need to know most of this stuff. It's interesting, okay? And here, our first time ever. So you do want to write this down. Not only is there all of the ices that you probably know about: water ice, carbon dioxide ice, ethanol ice or ethyl alcohol ice, methyl alcohol ice, ammonia ice, right? There's also oxygen and nitrogen ice, okay? First time ever finding molecular oxygen. So this is a pretty interesting thing, right? Just be aware that before this mission, we didn't know that there was oxygen ice. Now I can tell you there's oxygen ice. Where did it come from? Primordial, right? This is early. It came from even before the solar system, perhaps. Okay, so one of I feel like I should have prefaced this question a little bit, but being made of ices, one of the ideas people have had in the past is maybe the water that we have on Earth came from comets, right? And so I have actually consider that to be a viable idea. I thought, yeah, why not? That sounds like a good idea. Maybe the water on Earth came from comets. And so this is our very first opportunity to test the water from the comets and see if it matches the water on Earth. So there, the matching has to do with these isotopes. You don't have to worry too much about that. D is heavy water and H is the regular water. But if you look at this ratio, here's Earth, right? And it turns out that the comet that we're looking at right here is not the same. So at least this comet didn't supply the water on Earth. Actually, when you look at it, you see there's a big group of objects nearby, the asteroids. The asteroids have water too. And so this is actually a much greater chance of being where we got our water from, right? From the asteroid or from objects like the asteroids, okay? But not from the comet, okay? Sorry about that. I hate to disappoint you, but not this comet. Now, it could be another comet has a different flavor of water, right? A different isotope ratio of water. Could be from, different kinds of comets. What else did we find? Don't write this all down, but I just want you to be aware, right? When they looked at the coma, they found water, carbon monoxide, carbon dioxide, ammonia, methane, methanol, formaldehyde, hydrogen sulfide, hydrogen cyanide, sulfur dioxide, hydrogen, lots of things, right? And so that's amazing, right? We didn't know about many of these, and that's cool. All right, so our final little piece of the story, the Rosetta main mothership dropped the Philae lander down, and here it is, a little Philae lander. It's got a, if you look down here, it's got a harpoon. It's so cool. It comes down and lands on the surface, and there's not very much gravity on this comet. It's pretty tiny, right? So the idea is that as soon as it touches down, it shoots out a harpoon, sticks into the ice, and holds it down. That's the idea. Isn't that amazing? Such a cool plan. And so here it is, the last picture of the taken by the OSIRIS camera, right, from the mothership. There's a little Philae lander dropping down, and it landed, and then something bad happened. When it landed, it apparently landed on an area that was a little bit stronger. The ice was a little thicker, and the harpoon, which was supposed to penetrate the ice, didn't, and it bounced off and came down in a crevasse in a valley. And this lander is solar powered, and there's no sunshine in this little valley that it landed in. And so I'm so sorry to tell you, it lasted about 36 hours before it died. But it didn't give up easily. In fact, that whole 36 hours, they were doing measurements. So the communication between the mothership and the Philae lander allowed them to estimate that the porosity of the comet, how much empty space is there? And they found, I'll show you in just a minute, but they found even more empty space than the mission I told you about a few minutes ago. Okay, so that's kind of interesting. And also the Philae had these special sensors that allowed it to taste the chemicals at the surface of the comet, and it did that, and then it died. Okay, now they were hoping that the comet rotated, that at some point the sunlight would penetrate down into this crevasse and Philae would wake up again, and it did, only for about 8 hours, and then it went back to sleep again. Okay, so it was a pretty disappointing thing, but still, even with that limited life, they managed to get some results, and they even think they found it. Unfortunately, dead. So dead. So what did they find? They found 16 organic compounds, right? And these are again, remember, they have carbon in them. They're chains of molecules. Carbon's really good at doing that. There were alcohols, carbonyls, amines, nitriles, amides, and isocyanates. Okay, of these 4 organic compounds were detected for the first time on the comets: methyl isocyanate, acetone, propionaldehyde, and acetamide. Okay, so these chemical compounds are very much like things that we find in organic compounds on Earth, but also, as I mentioned to you, they're very similar to compounds that are found in human DNA, right? So that's kind of interesting. I don't know anything about why or what that means. I just want to share with you it's there. So here is the interesting thing. They found that the empty space was 75 to maybe 85% empty space, and it has a hard shell of water ice probably, but they also found these very long, complex molecules, and that is the first time we had conclusive proof of that, okay? So this is an interesting idea just to be aware of. Okay. So this is totally just a lighthearted little piece. There was a comet called Lovejoy a few years ago, and they found out that the comet was releasing as much alcohol as 500 bottles of wine every second. So some, if I were joking and you guys were here, I would say, imagine we got one of these comets and dropped it off in IV. How many hundreds of years would it last for all the people out there? I know, I'm sorry, if you have a drinking problem, that's probably not so great. Anyways, it's just, sorry, anyways. Okay, so they also found these other 21 different organic molecules, including ethyl alcohol and glycoaldehyde, a simple sugar. Okay, and that is it. There's a picture of a comet. There's actually a comet that is visible in the early morning. I haven't quite seen it yet, but I'm hoping to see it soon. And it has tail. There is actually a pretty good website I can show you. Let me show you this. Let's see if I can find a good website for you. This is Bright Comets. Actually, I think, let's see, Bright Comets. Let's see, Bright Comets. Where is Comet Watch? Okay, current observable comets, Comet Watch. And so you can see a list of comets. And the magnitude tells you how bright this is. We'll be studying that a little bit later. 8 is too dim for you to see with your naked eye. You need a binoculars or a telescope. And so this is visible in the Northern Hemisphere. Atlas is the name, and Swan. These are the two that we can see. So Swan is getting brighter, Atlas is getting dimmer. Okay, and Pan-STARRS is still visible at a magnitude 9. So the bigger the number for magnitude, the dimmer the comet. Okay, so that's it for my comet presentation. Thank you for your attention and have a good night, day. Okay, take care.